Assalamualaikum and hello everyone. My name is Syamim bin Jamil. My metric number is EA19003. Together with my friend Mohamad samsulsairi bin Saidi, number metric EC19002. Now I will present about antenna and propagation assignment 1. So our chosen article is article 11 or journal 11. So this is the summary of journal 11, wideband circular polarization reconfigurable antenna. So this antenna has a compact structure which consists of three substrates stacked together by four plastic screws as shown here. Four planar radiating arms and a feeding network are printed on the upper two substrates, and the DC biasing line are printed on the bottom substrate. All the substrates are from same relative permittivity, which is ER equal to 2.65, the thickness of 1 millimeter, and the loss tangent of 0.001. The antenna is centered fed by an SMA coaxial cable. Four radiating arms play as the radiating elements connect to the output of a reconfigurable feeding network. Two arms are printed on top surface of substrate 1. Another two arms are attached at the bottom surface of substrate 2. These four radiating arms are arranged in sequential rotation. To prevent the possible current leakage from the outer conductor of the cable, this design adds a short circuit sleeve balloon 20 with the length of 42 mm and diameter of 10 mm. Through the control of the pin diode biasing, the antenna finally realized the polarization switching. So next is Journal 11 antenna performance. So for the performance, reflection coefficient here shows the measured and simulated reflection coefficient for both mode. State 1 for RHCP and state 2 for LHCP. A large 10 dB impedance bandwidth of 80% from 1 to 2.35 GHz is obtained. Since the actual value of equivalent circuit for the diode may differ from the labeled value, the loading effect will also be different. Thus, there is some discrepancy from simulated and measured result. So, if we see next, we see the action ratio. Action ratio exhibit the measured and simulated AR bandwidth for both modes. The simulated and the measured results are in good agreement. The value of CP, CO pole, and X pole will change simultaneously according to the impedance. Therefore, the AR bandwidth are not affected by this discrepancy in impedance matching. The measured AR bandwidth for the LHCP mode is 37.8% from 1.5 to 2.2 GHz, and the corresponding values of the RHCP mode is 26.9% from 1.45 to 1.9 GHz. Okay, for the overlap, AR bandwidth for both modes is 23.5% from 1.5 to 1.9 GHz. So this gain here is present the measured gain across the operating bandwidth for both mode. So if we can see here, there are many gains. So we choose the highest is 2.5 dB. So next, let's see the comparison between uh, the our chosen article and other four article. So the wideband we have here wideband polarization reconfigurable antenna with strict polarization states. Wideband circle polarization antenna with L-shaped feeding probe. Wideband high efficiency polarization reconfigurable antenna for wireless communication. Reconfigurable single port antenna with circular polarization diversity. Wideband stack patch antenna for reconfigurable polarization application. So the gain for first is 2.5, the second is 6.9, 9 dB for high efficiency, 8.7 here, 11 dB. So directivity no. So bandwidth gigahertz varies from 1.5 to 1.6 here, and we can see here here is the highest wideband stack patch antenna. So efficiency radiation we can see here The single port antenna with circular polarization diversity is the highest. So I think that's all from me. Thank you.
For the design and performance, we design like this, and this is design of circular polarized patch antenna operating in 1.8 GHz using lambda over 4 transformer feeding. First design the ground, after that design the substrate. There is a lot of technique to design circular polarized patch antenna. One is cut the opposite side of patch antenna through corner of PF patch and etc. To make Atram Lam 2000 laminate Rogers HS equal 1.5 to 4, ER equal 2.6, and tangent loss equal 0.0019, and waveguide port. Choose the frequency minimum 1 GHz to maximum 3 GHz. So the antenna are designed and can simulate and check the result. The result like this, 3D far-field radiation pattern and polar plot for elevation angle. This is a Asia ratio frequency 3 GHz in 3D, in Cartesian, and in polar, polar. Asia ratio frequency at 1 GHz in polar and in Cartesian, and second Asia ratio frequency 2 GHz polar and Cartesian. The efficiency is red color radiation efficiency, and green color is the total efficiency. The return loss is when the minimum return loss 1. When frequency 1.5842, the return loss is negative 70.23468. This is a voltage standing wave ratio. This is a result for power loss in the electric power absorbed at all port. Blue color is power acceptor, orange color power outgoing all port, power radiator, power stimulator. This is a parameter we use, WG 116.3, LG 8T, HG 0.135, HS 1.524, WP 50.65, LP 50.65, WM 1.234, LM 29.45, LEF 28.42, WEF 4.315, IT 3.72. And hash field is like this, hash field pattern like this, and second, the surface current distribution at 3 GHz. We can see like this, maximum 39.0034 ampere. For discussion, describe the operating frequency of the microstrip antenna. In 1.5842 GHz operating frequency, the return loss curve has a return loss is less than negative 10 dB, which are considered as a very good antenna due to below 10% of the power delivered is reflected and above uh, 19% of the power is delivered to the antenna. For the radiation characteristic of the antenna produce maximum radiation in the broadside perpendicular to the substrate, and ideally no radiation in the end-fire. An antenna as heavy directive radiation and only operate well at single frequency narrowband. This antenna has low directive directivity compared to other antenna. What are the influency design parameter? The influency design parameter is the patch length, substrate height, patch feed, resonant frequency, and bandwidth of the microstrip antenna. When the substrate height increase, the fringing field will decrease, causing the patch length increase, and at the same time the frequency decrease. When the resonant frequency decrease, the gain will decrease. For the conclusion, as a conclusion, the main purpose of this lab is to design wideband circular polarization reconfigurable antenna, referring to the related journal review that was given by lecturer. In this lab, we can able to describe the operating frequency, radiation characteristic, influence, design parameter, and design an antenna that has a better performance with return loss below 10 dB for a good consideration of the design of antenna. That's all from me. Thank you.